Okay, so this is just to explain you what are the key factors that go into induction and how it all came about. If you look at, if I had to explain this to you in a very, very simple term, most of us today have seen an induction cooktop. So I'll take that example to explain the principle of induction heating. If you see this, you would have an induction coil placed below the surface, and on top you would have had a glass or a toughened surface or a plastic surface, which is non-metallic. You would have the coil designated. Now this is the coil, which is a copper wound in circles over here. This inductive coils in the cooktops typically operate at current at frequencies of about 20 to 40 kilohertz, which means that is the frequency at which the magnetic field will also be generated. These are the blue lines that you can see the magnetic field being generated. Now, if you switched on your cooktop and put your hand on it without any metals on your finger, you would not feel any heat, right? Because your hand doesn't conduct, there is no impact of magnetic field on your hand. But if you put a metallic vessel on top of it, when you added water or anything to it, the vessel would now be in the path of the magnetic field. Now this magnetic field, which is an alternating magnetic field, would induce current in the metal. And this orange zone shows that the metal will start getting heated up quickly. And since the metal starts getting heated up, it conducts the heat onto the object inside the vessel, that is your water, milk, tea, whatever you wanted to boil or cook. That's the basic principle of induction. Again, while this pot was boiling, you remove the pot, put it onto the side, take your hand and touch the surface of the where the pot was, you will not feel any heat. So it's a very cool and fast heating process. Important things to consider when we look at induction or when we talk about induction. One of the most important parameters is power. Now, power is current times voltage. So which current are we talking about? The current that is flowing through the coil that is generated, the alternating current. That determines the intensity of the magnetic field generated. The frequency of operation of the equipment decides these length of the magnetic field or the depth, right? So the higher the frequency, the shallower the penetration or the heating effect. So if you want to do case hardening, typically, you would have looked at one of these surfaces that you would be touching only the surface. If you wanted to reduce the frequency, so when I talk about high frequencies, I'm talking about anything over 100 kilohertz, you could consider it to be a high frequency. Above 450 kilohertz, you would consider it to be radio frequency, right? And that would give you really fine case depths. If you lowered the frequency, you would see more deep penetration or more heat going internally. And when you do it really low frequency, so you would be doing, say, something like forging, where you want to heat the billet completely inside out, or you want to do through hardening. At that time, you would be operating your induction heaters at a very low frequency, maybe 150 hertz, 500 hertz to about 1 kilohertz. That would help you do that. Now, what is the other thing that makes a difference? So if you go back to our example of the magnet, when you use a magnet on a paper, you have no impact and you don't feel any force in your hands by holding the magnet. But the minute you take the magnet close to an object which is metallic, you will feel a sudden force pulling the magnet towards the metallic piece or pulling the piece towards the metal. You would feel that force in your hand. Similarly, the distance between the coil and the job inside the coil, if it was too close to the coil, this is called coupling. The closer the fit, the more the heat transfer, the more the load that the equipment will take on, the faster will be the heating area. The poorer the coupling between these two, this would be a lesser coupled, it would heat lesser compared to this range here, okay? And so these are factors when we talk about induction that matter. These are just the concepts I'm sharing with you. When we go down to different applications, we will see more of these in detail. Next, if I look at it, one of the fun facts is that during the World War II, just years prior to World War II, a few companies had started working on induction as an industrial substitute for heating. However, it really became popular and it grew more intensely during the World War II, as there was an immediate need for producing large number of parts with minimal labor. I guess I wouldn't call this World War III, but we are in a situation right now which is very similar, where the time available in the year is going to be much lesser than the amount of work we would have on our hands to complete, which has begun as of now, right? So induction can play a good role for you to speed up the things